All right. Yeah, we are back. Yo, I'm tired. Well, that's great. That's great. Maybe you need to go and rest. If you are tired, go and rest. Go and sleep. It's not good for you to be tired and to be up and unrested. Go rest. Go rest. Please go rest. Yeah, go rest. And let's not take it as if like this is compulsory class and people are dragging their feet like, I have to be here. No, you don't have to be. Please, people, don't remember schools are officially starting for you on the 14th, so this is not really a must. So if please guys, don't feel don't feel forced. Anything done forced, yeah. So let me just say that like that. Nadia Masego, did I maybe miss grade 11 live? Did I maybe miss grade 11 live? I didn't have a live for grade 11. I didn't have one. Let me just establish. Actually, let's just do this. Let's establish which grades are here. If you can just in the comment section let me know what grade you are in. Yeah, because like literally just started 2 minutes. I haven't started anything, so it literally started probably 2 minutes ago. Zainab, yes, I do teach grade 9. Grade 11 next year. Yeah, so I do teach grade 9, but yeah, with grade 9, there's an alternative maths as a game session that I have, platform that I have, so please just go there. Okay, go there. You can go to that that section. Yeah, try and find that. Okay, yeah, that will help you. Okay, so today guys we are going to I hear you. Keep giving. Sure. Unannounced, just like that. Okay, guys, let's continue with exam type questions. We were 2 days ago, I think. Yeah, 2 days ago we started with exam type questions for sequence and series. So we are continuing on that mountain climb of exam type questions. Yeah, so this is where we are going to start. The 10th term, the question says here, the 10th term of an arithmetic sequence. I think by now, guys, we can differentiate between the 3 types of sequences, right? We have your quadratic sequence. And if you remember very well, we said our quadratic sequence is the sequence that has a second constant difference. That's quadratic. Arithmetic is that sequence that has a first constant difference. Then we have your geometric sequence, which has a first constant ratio. All right. So here we are told the 10th term of an arithmetic sequence is 32. The 10th term, okay, is 32. And the sum of the 4th and 5th term is 31. Hey, this question. Okay, let's check it one more time. It says the 10th term of an arithmetic sequence is 32. And the sum of the 4th, the sum, guys, hopefully we know what sum means. The sum of the 4th and 5th term is 31. The question says find the first 3 terms of the sequence. Okay. So here with questions like this, we need to first read into the statement and then we need to interpret and set up equations. All right, so this is like your simultaneous type equations for sequence and series. Okay, so we need to set up 2 equations. Our first statement here, which will help us set up our equations, yes, it's 7 marks. The 10th term of an arithmetic sequence is 32. What does 10th term mean? It means T10 is equal to 32. That's what the 10th term of an arithmetic sequence is 32 actually means. T10, term 10 is 32, right? Then it says the sum of the 4th and 5th term is 31. The sum of the 4th and 5th. So that's like T4 plus T5 is equal to what? 31. Now we need to then state T10, T4, and T5 in terms of A and D. Now I need you guys to help me. T10 in terms of A and D. What is T10 in terms of A and D? Right? T10, guys. I want to know from you, what is T10 in terms of A and D? Term 10. Okay. Thank you, Kulegani Ndlovu. I see you there in the comment section. So guys, I just want to remind you again that we should all know that the general term of your arithmetic sequence is given by Tn is equal to A plus n minus 1 times D. So if you say what is term 10, you are substituting in the place of n 10. That means in the place of n, you substitute 10 as well. So T10 in terms of A and D is actually A plus, what's 10 minus 1, guys, in brackets? 9. 9 what? 90. So term 10 is actually equal to A plus 90. That's what term 10 is. Okay. And guys, I need not kind of like remind us because we know almost that T1. So if you substitute 1, T1 is A, because if it was term 1, 1 minus 1 is 0. 0 times D gets rid of the D, and then we're left with A. So term 1 is A. Term 2 would be A plus D. Term 3 would be A plus 2D. Term 4 would be A plus 3D. Term 5 would be A plus 4D. Term 6 would be A plus 5D. Term 7 would be A plus 6D. Term 8 would be A plus 7D. Term 9, A plus. Term 10, A plus. So you guys get the point. That basically we can state certain positions of specific terms in terms of A and D. So if we come here now, term 10, we rewrite the equation and we say A plus 9D is equal to 32. That is going to be my equation 1. All right. That has been actually taken from the fact that we learned that the 10th term of an arithmetic sequence is 32. So that means term 10 is equal to 32. But what is term 10 in terms of A and D? It is A plus 90. Substituted into the general term, term 10, as you saw me substitute and actually express, is A plus 90. So that means A plus 90 is equal to 32. That's our equation 1. Let's move on to the next equation that we need to set up. What is term 4 in terms of A and D? Now in the comment section, I'm expecting you guys to tell me what is term 4 in terms of A and D. Let's just focus on term 4. We are going to go to term 5, but what is term 4 in terms of A and D? Okay, thank you. A plus 3D. Ngwato says. Mr. Virtue says A plus 3D as well. Seems like Ngwato and Mr. Virtue are saying A plus 3D. I think Ngwato has even gone to the extent of actually telling us what term 5 is as well. Then Ngwato went ahead and actually simplified and gave us the whole entire expression. Okay. So yes, guys, you are correct. Term 4 is going to be A plus 3D. But we add that to term 5. And term 5 is actually going to be what, guys? As Ngwato has said, it's going to be a plus 40. So the summation of term 4, which is a plus 3d, plus term 5, which is a plus 4d, is going to give us what? 31. That is going to be our equation 2. Okay. Then, of course, guys, we have to simplify this particular equation so that we have it in its simplest form. Equation 1 is already in its simplest form because a and 9d are not like terms. They are unlike terms, and so separate and apart, on the left you are going to have a plus 9d, and on the right you are going to have 32. Whereas with equation 2, we can simplify. Okay, so the two things we need to take into consideration here with these simultaneous type equations is, one is setting up equations using a and d. If we are dealing with a arithmetic sequence, then of course it is a and d that we are going to use. But if it was a geometric sequence, our expression would not be in terms of a and d, but it would be in terms of, and I'm going to leave that to you to tell me in the comment section. If it was geometric, if the two sequences were geometric, what would be our expressions be in terms of? Would they still be in terms of a and d, or would it be some other thing? All right, because remember, since it's an arithmetic sequence and we're told it's arithmetic, we used a and d. But if it was geometric, when we set up our equation, would it still be in terms of a and d? No ways, guys. Thank you, 26 in the comment section. It would be in terms of a and r, because the general term of our geometric sequence is Tn is equal to ar to the power n minus 1. And that is what we would actually utilize to set up our equation. So please, guys, step number 1, read the statement, then set up your equations, and then express them in terms of a and d if it's arithmetic sequence. But if it's geometric, you express it in terms of a and r. So let's simplify now. Step number 2, we simplify if there is a need. So here in the second equation, there's a need to simplify. Our second equation, like terms, a plus a is going to give us 2a, 3d plus 4d is going to give us 7d, and then we are going to have that being equal to 31. So that is equation 2 in the best possible state, simplified. All right, so we have equation 1 and we have equation 2. Step number 3, in grade 10, hey guys, you see, grade 10 seems to be popping up a lot nowadays. There are two methods we can use to solve a simultaneous equation when we have two linear equations. Remember, a plus 9d is linear, 2a plus 7d is a linear equation. So there are two methods. You can either use the substitution method, or if you are someone else, you can use the elimination method. All right, so guys, it doesn't really matter which method you use. It's really up to you which method seems to flow best with you. So for instance, I really love the substitution method because coming from grade 11, you know, substitution method was what we were using even in grade 11 when we were solving a simultaneous equation. So you grab one of the equations. So for instance, equation 1, all right, you can see that the coefficient of a here is 1. So you make a the subject of the formula for equation 1. So I'm going to do that. Take equation 1, a plus 90, I take the 90 over. So it's a is equal to 32 minus 90. And then I refer to it now not as equation 1, but as equation 3. Then what do I do after that? I substitute equation 3 into the equation that was not manipulated, equation 2. So that means where a is, in the place of a, I'm going to substitute 32 minus 90 in the place of a in equation 2. So let's go 2, this 2, followed by the a in the place of a in brackets. Remember guys, when I substitute in a simultaneous equation, I use brackets to substitute. So in the place of a, I'm going to write 32 minus 90, followed by what? by plus, followed by what? By 70, followed by what? By 31. That is my equation 2 that I'm substituting in using equation 3. Then I think from there you guys should be able to easily solve. You apply the distributive law because BODMAS is applied. 2 times 32 is 64. 2 times 9, negative 9 is negative 18d plus 70, which is equal to 31. You then transpose, right? All the constant terms. Negative 18 plus 70 gives you a negative 11d. You transpose the 64, 31 minus 64. It becomes on the other side. So negative 11d is equal to what's 31 minus 64, guys? Mr. Virtue, please pay attention. You took this equation. Mr. Virtue, are you with me? Because you see now you are asking things that are obviously there. You see where there's you see this equation, a plus 9d. I took this equation, made a the subject of the equation. In other words, I isolated a on the left hand side, which means 9d, which is positive, gets transposed to the right. That becomes 32 minus 90. So a is equal to 32 minus 90. This now equation 1 is your equation 3 because a is the subject. You take this equation 3, you substitute it into the other equation which you did not touch, this one, equation 2. Do you see equation 2, Mr. Virtue? Do you see equation 2? Mr. Virtue, equation 2 starts with what? Look at it. It's 2a. So where now you have a as the subject, where a is in this equation, you are going to substitute 32 minus 90. So in the place of a here, you substitute 32 minus 90. So you're going to write now this equation 2. And when you write it, you are going to start with what? 2 followed by what? A, but you know that where a is, you are substituting what? 32 minus 90. So in brackets, we always substitute using brackets. You don't just write, you substitute using brackets in equation 3. In equation 2, that's why I wrote here, substitute equation 3, this equation, into equation 2. So I'm taking this and substituting where a is, I'm substituting 32 minus 90. So 2 brackets in the place of a, 32 minus 90, plus 70 equal 31. Okay, now do you understand where the 2 comes from, Mr. Venture? Because to me, okay, those things make me feel like that means if Mr. Virtue is having a problem or having an issue of not knowing where the 2 comes from, then rest assured, Mr. Virtue most likely has a problem with solving simultaneous equations, even in grade 11. And rest assured, most probably when Mr. Virtue was writing his grade 11 end of year paper this year, the final November paper, simultaneous equations may well have been a question that was not answered 100%. Okay, that's for me what it indicates. So the gaps that are there, because guys, let me tell you this: you are going, if you're going to grade 12, your grade 11 work needs to be solid. You need to be 100% fine. You need to know how to solve an equation using the quadratic formula, solve an equation, factorizing, solving simultaneous equations, surd equations. Remember everything that's attached to that, inequalities, nature of roots. You still exponents, exponential equations, everything needs to still be fine. Because if those skills, if anything is still lacking, it's going to affect something here. I promise you. And when it does, it's going to affect how you do in grade 12. So let us make sure we are solid in our understanding of the things we've done in grade 11. Close those gaps. 31 minus 64. Okay, you guys have already established it's negative 33. We divide both sides by what? The coefficient of negative 11. Of negative 11d, which is negative 11. You divide both sides by negative 11. D is equal to 3. But we are not only interested in finding D, we want to find A because we want what at the end of the day? The first three terms. So the constant difference is helpful. So we are going to take the D. Who is waiting to find A? It's the equation that you manipulated. A is ready to be found. All you need to do is substitute D, which is what you have found, and then find the value of A. All right, so you substitute the A is equal to 3, the D is equal to 3, where? In the equation that you manipulated. So we go there, A is equal to 32, we substitute in the place of D. What? 3, that's positive. That will give you 32 minus 27, and 32 minus 27 gives you an A, which is equal to what? You see, people are saying 4. Are you kidding me? 32 minus 27 is 4. These are the things, guys, that guys, let's tighten up the oh my goodness. Imagine asking a grade 8 learner what's 32 minus 27 and then guato. Yo, hi, happy birthday, Beyonce. Hi, happy birthday. Hi. Shooting happy birthday, Beyonce. Yo. Ayini kaizini. Guato, you could. Yeah. You see, this is the thing. Guato, please, if you are here to make jokes for the sake of making jokes, my friend, and you are making light of things that are very serious, because it's not going to be a jokey affair. Guys, these are the things that separate, like someone getting, a 67% for maths versus a 75 or an 80. Because you make these silly mistakes. You see how those silly mistakes, they culminate and they add up, and then it's like a loss of marks, a loss of many marks. And then you get the marks that you don't deserve because you are silly. Silly mistakes. Yeah. And I don't know, me, I can't tolerate silly mistakes too much, eh? Yeah, 32 minus 27. Please, guys. It's 5. So the first three terms, the question was saying find the first three terms. We are not done. So what now we need to do is write down the first three terms. Our first term is 5. What follows that 5? Constant difference. We know most. We add 3. So the next term will be, and the next term will be, you guys tell me. You tell me what the first three terms are so that I can write them down. Miss Zim, hi, hello. So yes, 8 is the next term. Yes, Cassidy Keating, it's definitely 8. And then followed by what? By 11, right? So at least we got the hang of constant difference. Guys, please, all right? This is a nice question. Okay, yes, and as you saw it, rightfully so, 7 marks. Rightfully so, 7 marks, because it's got all those components which are important. Okay, let us recap again. As I said, you read the statement. From the statement, you set up your equations. It's important to know how to write. It's important that you know how to write your terms. Yeah, term 1, term 2, term 3, term 4 in terms of A and D for an arithmetic sequence. And it's important that you know how to write your terms in terms of A and R for your geometric sequence. When you know how to do that, setting up an equation should be doable. Term 10, you know, is A plus 90. Term 4, you know, it's A plus 3D. Term 5, you know, is A plus 40. And you need to know how to read, and interpret mathematics from a English statement. All right. This is only helpful really for grade what? For grade 12s, because they are doing sequence and series, arithmetic sequence and geometric kuhle, you know. Yeah, I wouldn't necessarily like chase you away if you are grade 11, because you'll be doing this next year. If you're going to do grade 11 next year, then next year you'll do grade 12. But I'm just saying it's more pertinent to a grade 12 learner, and yeah, it's for them more than anyone else. So please guys, 10th term of an arithmetic sequence is 32. There we interpreted it there, and then we were able to write the equation in terms of A and D. Term 10 means A plus 90. Term 4 means A plus 3D, because we further learned that the sum of the fourth, sum means plus, of the fourth means T4, and fifth term means T5 is equal to 31. There we have it. So term 4, A plus 3D, plus term 5, A plus 4D is equal to 31. Then we added our like terms. We had our two equations simplified. Then after that, we decide, are we going to solve these two linear equations using the substitution method or the elimination method? So we all went for the substitution method, and we solved. We took the equation that has the coefficient that is 1, and we made A the subject, because we can see it's got a coefficient of 1, and then we wrote it in terms of D, 32 minus 90. Then we took that equation and we substituted into the equation that was untouched, and then we did what? We solved for D. Okay, remember here in the place of A, we substitute 32 minus 90, 2 into brackets. We use brackets when we substitute something. A is 32 minus 90, so that means where A is, we substitute 32 minus 90 in brackets, plus 70 is equal to 31. All right, then we solved for D. And this is just a simple grade 8 equation. At this stage, you are dealing with a grade 8 equation where you have to solve a linear equation using your methods in grade 8. You are in grade 11, so you should be proficient in doing this, no problem. You distribute, add like terms, isolate the variable, and then you divide by the coefficient. You get the value of D. After getting the value of D, you take that D value. Equation 3 is ready. A is already isolated. This equation is waiting to say, take the D, substitute, and get the value of A. And yes, Ngato, if you wanted to, you could take that D, substitute it in equation 2 if you want. Or you can take that D and substitute in equation 1 as it is. Okay, but it's just that it's more convenient to substitute in the equation that is ready. You prepared this equation, use it. You prepared it, use it. It's like preparing a fire and you just decide you want to go and braai at your next door neighbors instead of braaiing on the fire that you prepared. I mean, braai on the fire that you prepared. Come on, take the meat, put it in, and get your finished product. I don't understand why you want to braai somewhere else. All right, and then after that, you formulate your 3 terms, because the question was saying find the first 3 terms. Okay, so all of this was all the means in which you were trying to get to the point where you could answer so that you could get the 7 marks. Do you think we are deserving of getting the 7 marks? Oh, most definitely. Most definitely. Okay, I wouldn't rob us of these 7 marks even if you begged me to. Okay, Phoebs is like, where can we find similar equations to this one? Like I said, these are exam type questions. So when you have done sequence and series, meaning you have done the topics, like most of some of my learners that I'm working with, some of them have joined the live lesson, they are here, some of them like probably feel like they'll catch up on the live lesson as a video, they'll watch it on YouTube at their own time. Okay, some of my learners have already finished sequence and series on their own, meaning they grabbed the textbook, whether it's Mind Action Series textbook or it's Kevin Smith or it's Platinum. You grab the textbook, and as a grade 12 learner, you start acquainting yourself with going through material. You start from the beginning and you read and you use your language skills and your comprehension skills that you've been taught so well for the past 12 years, and you just go into that thing and you start going through page by page. You go through the worked examples. If you are lost or stuck, you ask someone that can assist you and help you. My learners ask me so that I can assist them. If they are lost somewhere, if they are stuck in something, they ask me. I am able to clarify those things, and then they are able to move on. So some of them have finished the sequence and series on their own. Obviously, not only just using textbook, but also when they are stuck, using other resources and material, YouTube videos, and other good YouTubers. Then at the end of the day, when you're finished with that, and you've done the exercises, you do all the exercises in the textbook one by one. And when you are lost, you ask questions, right? Then after you're done with doing the exercises in the textbook, then you grab past papers. You have a library of past papers, guys. From 2014, since papers have been set, since the introduction of CAPS, and up until now, 2025, your November papers. You have November, June, September trial papers. There are a variety of questions that are being asked and that have been examined to learners for the past few years. You make it a point that you practice those, and then you cover all the bases. So that's how you get exposure to some questions that are like this. It's by doing that. Okay. So anyways, I think let's move on to the next question. There's another question that's waiting. It looks like it's 7 marks as well. 7 marks. Silver marks. Okay, let's look at this one. The sum. The sum of the first 3 terms of a geometric sequence is 40. The what? The sum of the what? The first 3 terms of a geometric sequence. So this time round, we are dealing with what type of sequence? Very important to know which type of sequence you are dealing with. Each scenario exposes you to a particular type of sequence. When you know that type of sequence, then it makes it easy for you to be able to know, okay, this time round, I'm going to do things this way because I'm no longer dealing with an orange now. Eating an orange requires me to peel, remove, then after that, I eat. But if I'm eating an apple, no real need to peel, I can just So you must know what you are dealing with. Geometric sequence is 40. The sum of the what? The first 3 terms, okay, is 40. And the sum of the next 3 terms is 5. So the first 3 terms, the sum of it is 40, and then the sum of the next 3 is 5. The question is, find the value of the first term and the common ratio. I feel like I need to give you guys a chance to do this one on your own. Okay, so I'm gonna give you 7 minutes and I'll just not do anything, allow you guys to do it. I'm hoping you guys have a book, pen, open in front of you so that you can say, you can actually vouch and say, during the holiday, even though I did not really think I was going to be doing maths the way that I'm doing it, there was this crazy guy that would actually come live, and that guy, he would really harass me, but yeah, he helped me. So yeah, let's see what you guys think and what you maybe can do with this question, and then we'll take it after you are done. Yeah, I'll give you that 7 minutes. I think it's worth. You want me to do that? Gamer Boy Joy, is it Gamer Boy Jaws? Are you going to do a video about the term 1 to 4 topics? You want me to do that? I can always do that if you want me to. Just ask me nicely. You are asking me, are you? Maybe Game Boy Joy, you can say, may you please? And yeah, I'll be happy to do that. You want to know term 1 to 4 topics, but you guys have an annual teaching plan. I don't think you really need me to do that. And I know a lot of people do those videos. A lot of content creators, maths creators. There's even people that are amazing, phenomenal, above and beyond what I do, Shem. Yeah. May you please say what, Cassie? What do you mean? May I please what? for maths, Kalo. It's just for maths, guys. I'm not like your other content creators that are amazing that do both. I do maths only. I'm a maths guy, maths boy. I respect those who do both math and science and appreciate them. And I hope you guys take the time to follow them and follow through with their content. Amazing people. There's like phenomenal people. Like I said, I'm just using the little bit that I can use here and help and assist where I can. So, okay, I see. May you please say, okay, Cassidy, I hear you. Oh, okay. No, I'll do it. I thought you were like saying, may I please do this problem? I understand you now. Okay. No, Demarks, I don't do for Maths Lit. I think Maths Lit students, I thought Maths Lit students know they know their stuff. They can do their thing. Blessing overflows. Thank you, B. Thank you, Gamer. Okay, time is ticking, guys. I hope you are making headways there. It's coming together, the problem. I hope it's coming together, you know. But sometimes it's hard. I hear you, Demax. I hear you. Yeah, the thing is, there seems to be a serious problem with pure maths. That's the thing. You think about how many learners across the country do maths literacy in comparison to pure maths. There's a larger volume of kids that are doing maths literacy than pure maths, and there's a serious challenge. I was blessed, for instance, to be one of the markers at the marking centers for the exams that were written. And I was marking maths paper too. Sure. Yeah, there's definitely challenges there and there in certain areas of the country when it comes to maths. So any help, if there's anyone in this live, maybe you are here not because you are here to learn, you are just here because you just love maths. But you know what? You've got a skill of teaching mathematics and you finished high school a long time ago. And maybe you're at university, you do tend to have time in your hands. Let me tell you this, man. This is a labor of love. If you can start TikTok, do live lessons, give kids like an opportunity to learn, you've got the skill, if you can do it, man. Rera, you're just here for the love. You see, people like you, and I'm sure, Rera, you are someone who can, help and assist our learners in the country, man. We need help. Like, learners in the country need help. They face unique challenges, in respective schools and classrooms are not the same, man. And some learners are not privileged to have, teachers that can actually teach them the way that they would want to be taught. So yeah, guys, if you can, like I said, because for instance, you see this maths is a game platform. I started this thing so casually. When was it? 2025 now. 2024, last year. Towards the end of the year, last year. I remember just thinking to myself, I'd like to help. So I started like this channel and like maths is a game, and I posted videos like where I was explaining certain things, and I would get like 5 views, 2 views, 10, 11, we wouldn't get more than 100 views, and followers were just not here at all. Then I started doing live lessons, and like few people would join, but like slowly but surely it picked up traction. And then like the platform just exploded and grew, and like learners were like saying, let's start WhatsApp groups. Man, let's do this, do that, do this. And I was like, okay, let's do it. And before I knew it, this platform was booming, man. And not only grade 8s and 9s was I helping, but then like I started helping grade 10. Initially it was focused on just grade 8s and 9s. And then like slowly but surely I just shifted and started helping grade 10s, 11s and 12s as well. So and it's beautiful for me to see, like, there are learners that I know very personally because I've gotten to know some of you very personally. and whom I stay in contact with, and many of whom are doing amazing, like in their respective schools. There's a particular learner in grade 12, for instance, that is going to grade 12 next year, but grade 11 last year was just doing amazing things. Like, term 1 got like 90 something percent for maths, and like throughout the year was just doing phenomenal. Ended off the year in style, even like towards the end of this year, with final exams like getting like 94% overall for mathematics. And they were having a unique situation in her school, because sometimes she would actually like step in class and teach herself, because she was getting help from me via the live lessons, and she would actually take those and go and teach in class when the teacher wouldn't be there, because oftentimes the teacher would leave her to teach. so she was like, she would use the live lessons, she would use the videos I would do, and she would go to school and teach her fellow learners. And by that, she would just get better and better and better, till like she's just so self-sufficient and independent. She's doing phenomenal, and I know in grade 12 she'll do phenomenal. So that's what I mean, guys. Whatever help you can lend, you can extend. If you are able, please do it. Each time, my brother, especially when you are in cybersecurity space, you barely have any. Oh, okay, Rera, I hear you. Man, Rera, you should plug me with the cybersecurity. Please, yo. Yeah, Rera, definitely. Rera, we need to have I think I need to get your contact details. Please inbox me. I think you and I we need to connect. Cybersecurity kind of like it intrigues me. I'm not gonna lie. It's kind of an intriguing path. Okay. Okay. So I'm hoping, guys, no time. At least I gave you sufficient time. Hopefully someone has gotten somewhere, and as we attempt now to answer this, we are good. That's what I want, finishing term 1 content before it starts. Yeah, Mzala. Then Mzala, you get there at school, bruh, and people are like, what's up with this guy? You have a special walk, you have this special walk, because your mind, you are so confident because you know what you know. And it's like, it's a matter of like, when you are in classroom now, when the teacher teaches, it's more of like you can engage and ask questions related to things maybe that you might still feel that you are shaky and you are not as firm and solid in. Yeah, you become a help, you become a benefit in the classroom. And some learners will start sort of like turning to you for help and assistance, and that in and of itself will also fuel your confidence. So you want to change the narrative completely of how you are perceived even at school, and and then help others that may need the help. Okay, so the sum of the first 3 terms of a geometric sequence is 40. Guys, sum of first 3 terms, I think we all know what sum means. Then we know what first 3 terms is, and we know what a geometric sequence is. So here, what are we envisioning? When we talk about that, we are thinking of term 1, term 2, and term 3 added together being equal to 40. And basically, term 1 in terms of A and what? And R. Term 2 in terms of A and R. Term 3 in terms of A and R. I think basically that's where we are at with this particular problem. We want to be able to express term 1, term 2, and term 3. Hi, Moshi. We want to be able to express these terms, grade 12s, in terms of A and R. So, any guidance? Hello, guys. I'm sure you are done, or do you guys still need more time? Because I don't want to. Okay, so let's set up the 2 equations. Let's set them up. Hi, Moshi, you kill me. All right, so it's going to be A, that's term 1. Term 2, AR. Term 3, AR squared. Okay. I know, it's fine. I've got you guys then if you don't have your pens and pencils around. Okay. So remember, guys, why am I saying that? Remember, this time round, it's a geometric sequence, and your general term for a geometric sequence is Tn is equal to AR to the power n minus 1. So term 1 is going to be AR to the power 1 minus 1, which is AR to the power 0, which is A. That's term 1. So that's why I am saying term 1 is A. What about term 2? AR to the power 2 minus 1. That basically means AR. AR to the power 1. That's term 2. Term 3, obviously, guys, I'm sure by intuition, AR to the power 2, because it's going to be 3 minus 1, which is 2. Term 4, 4 minus 1, which is 3. Term 5, 5 minus 1, which is 4. Term 6, and so it goes. Are you with me? So we need to be able to express our terms in terms of A and R when we are given such statements mathematically. We need to be able to interpret the English to algebraic language, algebra language. Okay, yeah. A plus AR plus AR squared is equal to 40. That's the sum plus of what? The first 3 terms. What's the first 3 terms? Term 1 is A, term 2 is AR, term 3 is AR squared. Equation 1. Then, and the sum of the next 3 terms is 5. The what? The sum of the next 3. Now, next 3 means AR to the power 3, AR to the power 4, and AR to the power 5. It's equal to what, guys? 5. Equation 2. Okay. Chomi Mara, it's December. Are those like tears of joy, Chomi? Yeah, and remember, it's gender-based violence when you decide, I see you've got the purple color. It's gender-based violence when you decide to come into my live and tell us it's December, but Tina, we want to actually sharpen our minds for January, because we know January is a tough month and the school begins that time. And Tina, we want to be on top of our game. So Mara, you must consider that, ne, Chomi? Yeah, before you comment in my live section. Gender-based violence, you are violating us. Okay, A plus AR squared is equal to 40. AR to the power 3 plus AR to the power 4 plus AR to the power 5 is equal to 5. I hope we understand this, guys, the setting up of our 2 equations. Okay, now the next thing that we need to look at, is it possible for us to actually simplify this any further? Guys, it's very apparent that that will not be possible for us to actually add. There's no like terms here. Okay, but here is something that can be done by who? By you and I. Here's something that can be done by you and I. And I'm sure if you guys take a very special look, you are going to see, okay, we can take out here the common factor, some common factor, all right, so that we can eliminate something, all right, because once we take out that common factor, then we are going to not subtract from the 2 equations, we are going to divide and eliminate what is common, so that at the end of the day we can actually arrive at the answer. All right, so this is an important skill as well, because once we are able to comprehend it and see it, then it actually helps us a lot. All right, so what I'm going to do, I'm going to take out the common factor, the highest common factor there in my first equation. Do you see, guys, in my first equation what the highest common factor is? Can you see it? Can you behold it? Can you behold what it is? So what is my highest common factor? Thank you so much, Sbusis. Oh, Sbusis, when you are a blessing, my friend. Your name itself is it's encapsulated in your name, man. I really appreciate it, man. Like, it means a lot. This thing of 20, you awesomes, I really appreciate it. You make me feel awesome. By the way, hey, there was when I wrote the question, this was supposed to be, the term is -5, okay, not +5. So I'm sorry, let's just fix that. That was supposed to be -5. So what's the highest common factor there, guys, in my first equation? AR plus AR squared is equal to 40. If you take out the highest common factor, yes, Mushi, yes, Mzala, A is the common factor. So if we take out, we have A, then what are we left with? 1 plus R plus A, no, can't be A, R squared, okay, which is equal to 40. Okay, let's move on to the second equation. I think we can see there's commonalities as well there. Highest common factor, A is the highest common factor. R to the power what? 3, not R to the power 2 or anything. It's R to the power 3. So we're going to take out AR to the power 3. Because remember, for our variables, we take out the common base with the lowest exponent. So if we look at R to the power 3, R to the power 4, and R to the power 5, the highest common factor is the base that has the lowest exponent. So R to the power 3 has the lowest exponent. When we take it out, what is left there? 1 plus, what's left here? R. Then what's left there? Plus R squared. Guys, do you see? Ooh, this is so amazing. This is so great. It's making life so great. Okay. Yeah. So this bracket is going to disappear. I get. It is, right? Because we are going to divide the two equations. Okay, what are we going to do? We are going to divide the two equations. Why? So that we can eliminate what's common. All right, so we're not going to subtract the two equations, we are going to divide them. So we are going to take equation 1 and equation 2. Then we are going to say equation 1 divided by equation 2. When that happens, what's A divided by A? A actually says goodbye, because A divided by A is 1. Then 1 divided by R to the power 3. So I'm going to have 1 divided by R to the power 3 here on the left-hand side. I hope that makes sense, guys. Because if you say equation 1 divided by equation 2, A divided by A is 1. Okay, those two cancel. Then 1 divided by R to the power 3. Remember that this cancels out because it's common when we divide. It leaves me with 1 and 1 at the top. So at the top, in actual fact, I'm left with 1. Okay, there, 1 over R to the power 3. Because I've divided equation 1 and equation 2. On the left-hand side, I'm left with 1 over R to the power 3. Let's go to the right-hand side. On the right-hand side, 40 divided by -5. Guys, what's 40 divided by -5? Okay, so for our geometric sequence, we divide the two equations that we have set up in order to eliminate. All right? Mzala, thank you. Okuhle. Hey. 40 divided by -5 is -7. Okuhle. I love your name. I wish you were Okuhle and you were Muhle, even in the answers, you know. Yeah, thank you, Sir Opulence, Miss Zim, Cruise. You are cruising there, my friend. Yeah, -8. All right. -8. So far we are good, ne? So far so good. I hope so. I really hope. I hope we are flowing nicely, because it's important that we flow nicely. Then, if you want you could actually take the cube root on both sides. You could, right? Or I think more appropriate, you can say r to the power negative 3. If you write this 1 over r to the power 3, remember exponents, you can write this as r to the power negative 3, which is equal to negative 8 as well here. Okay, then what do we do here, guys? We raise this to negative 1 over 3. But remember, what we do on the left, we do on the right as well. We raise this to the power negative 1 over 3. This becomes, because it's odd, the sign does not change. The sign remains as negative. But the answer here will be r is equal to what? Okay, you see, most this is negative 2 to the power 3. Okay, that's what you would do actually. Then it's r is equal to negative. It's going to be 2 to the power negative 1, which is actually r is equal to negative a half. I hope we understand that. 2 to the power negative 1, any exponent raised to a negative will give us 1 over 2. Okay, so therefore the answer is actually negative a half. Yep, yes, we good. Remember the question, what did it ask for? It wanted the common ratio or the constant ratio, but not only that, as well as the first term. So we have r, we can find a. How do we find a? We go and substitute into one of the two equations, any one of the two, right? We take r, we go and substitute in any one of the two equations that we had listed there above, and then we can find Mr. A as well. So I'm thinking of this equation specifically. I'm just going to say a into 1 plus negative half plus negative half to the power 2 is equal to 40. I'm just going to grab my calculator because all I want is just what I get there so that I know what a is multiplied to. Then I'm going to divide both sides by that coefficient to get the value of a. So just going to punch all of that. 1 plus positive times the negative is going to be negative half. So I'm just going to say 1 minus half. And then I'm going to say plus. Okay, definitely plus because this negative half is inside the squared. So I'm just going to put that in brackets and then say negative 1 over 2, then put it in nice bracketanyana, put the square on the outside, and then I want to know what the value is. It's 3 over 4. Okay, so I have a 3 over 4a is equal to 40. Then I think from there we can solve for what? For a, guys. Divide both sides by the coefficient, which is 3 over 4. Or we could multiply by the reciprocal, 4 over 3 on both sides. It's really up to you what we choose to do. Divide by 3 over 4 as well there. So a is equal to what's 40 times 4 over 3. You can put in your calculator 40 times a. And we have that 3 over 4. So that's 40 times 4 over 3. That gives us 160 over 3. Okay, and that's as simple as the answer can get, 160 over 3. So that's fine. We just say a is equal to 160 over 3. We can leave it as that improper fraction, or if you really want to insist, you can write it as a mixed number, but leaving it as an improper fraction is fine. All right, so that's basically that question. 7 marks. 7 marks worthy. Do we feel that 7 mark worthy mark? Guys, do you see that our exponents and surds here? Now your exponents, your knowledge of exponents is coming into play here. All right. Also the division, because what happens when someone says a divided by a is 1, and then they say this divided by r to the power 3 is actually equal to r to the power positive 3. They don't think of the fact that it's 1 over r to the power 3. That speaks to a lack of understanding in what is left behind in the numerator. And that would obviously mislead you and lead you to getting a wrong answer. So that's why it's important now, guys, to make sure. That's why I was saying to you guys that your foundational basics in all topics that you did in grade 11 and 10 are going to be so important for all your topics in grade 12. To the extent that if you have a information gap somewhere, you're going to see how it's going to affect you in the topics that you do here in grade 12. So please, guys, make sure you polish up in your basics in your previous grade work. Please. What will happen if you divide equation 2 by equation 1? You will still get to the same. It's still the same thing, right? So if you said equation 2 divided by equation 1, what would be the outcome? A divided by A would still be 1. R to the power 3 divided by 1. Remember, this would be in the denominator. So it would be actually be on the left, we'd have R to the power 3, right? Then here on the right hand side, it would be negative 5 divided by 40. So you would have, what's negative 5 divided by 40? Remember, this would be treated as if it's in the numerator and this is in the denominator. Negative 5 divided by 40. That will give you a negative 1 over 8. Negative 1 over 8. Does that make sense? Okay. Even if you get a wrong answer, let's say value for R. Ultimately, to test your answer, you substitute. Yes. Very important. Okay, very important. Very true, Rera. Thank you so much for that input there in the comment section. So yes. All right. So if you said equation 2, that's fine. You could also say equation 2 divided by equation 1. And when you do that, this would be your outcome, left and right. Yeah, because now you are treating the equation that you are beginning with, you are treating it as the numerator, and you are treating the equation that you are dividing by as the denominator. So A divided by A is still 1, but R to the power 3 divided by the cancellation, there's 1 in the denominator. R to the power 3 over 1 is R to the power 3 at the end of the day. On the left hand side, you have R to the power 3. Then on the right, what's negative 5 divided by 40? It is negative 1 over 8. So that's basically it here. Then you solve for what? For R. So of course, when you solve for R, you could actually take the cube root on both sides. Okay, if you wanted to, or you could raise it to the exponent, the reciprocal, which is 1 over 3. You'd still get to the same answer. So answer at the end of the day is still negative 1 over 2. Do you see? Then you take the R, you substitute it back into one of the two equations, and you get the answer. Yes, maths in December, definitely. That's good, Guado. I'm happy that you are sharpening your mind like that. Okay, sharpen it, my guy. It's so important. It's so crucial that you sharpen the mathematical skills, guys, need to come back, and they need to be top notch. Yeah. Thank you, Moshi. Moshi, I think since you are here and you are in another grade, let me do this. Help me out here. You can help me out. I think let's do this. Let me officially appoint you. Those are privileges. Let's make you moderate. Mushi, please be my moderator there, and just when there are funny people like those ones that come here and they post December, you can mute them, you can block them, and all of that stuff. I really don't want to be dealing with these people, any longer than I am. All right. So, okay, I hope that's clarified. Is there any questions, guys, about this question that we've just done? So, yeah, you could take the second equation, divide the first one. When you take the second, you divide by the first, then basically that's what happens. If you take the first, you divide by the second, that's what happens. You know what I mean. I hope that's clear for you, Ngwato, especially Ngwato, since you've been asking all these important questions, pertinent questions there in the comment section. Thank you. Okay, thank you, Moshi. All right. Yeah. That question was nice and meaty, guys. 7 marks. We do 2 7-mark questions in a row. Okay. And I actually want to test you guys here. And yeah, we'll come back now. Umzala. Yeah, you see what you are saying now, doing another question. That other question, you are going to be the one that actually makes sure now that you take care of the questions, you see. You must be the one now. You must be the one that looks for more questions. Me, I will just expose you, get to give you a taste, there and there. But at the end of the day, you are the one now that has to, practice and do more questions so that you become more familiar with other questions. Okay, so let's move on. Yeah, we need to, me, I'll expose you there and there. When you must be hungry and go and look for more. And make sure that you tear them apart, those questions, when you find them. New generation, yes. As long as there's breath in my there's breath, as long as I have breath, I will be doing live lessons in New Generation. Consider the following geometric series. 3 into x minus 1. You are laughing to me. You are laughing. 3 into x minus 1 plus x minus 1 the whole thing squared plus 1 over 3 into x minus 1 to the power 3 plus ... where x cannot be 1. Find the value of x for which the series will converge. Converging series. Yeah. Don't worry, it's the opulence. Yeah, but we try very hard to not leave the English behind. Do you know now that these people, they are trying to get maths students through the English. So we must also make sure our English is fine, especially our comprehension, because sometimes word problems, they become wordy and we are unable to interpret them. So we're also trying to get the English to be fine. Okay, yeah. Consider the following geometric series. There it is, guys. You can see the geometric series, and they are saying 3 into x minus 1 plus brackets x minus 1 the whole thing squared plus 1 over 3 into x minus 1 to the power 3 plus, and then they say x cannot be 1. Find the value of x for which the series will converge. So what kanene do they mean by converging series? Anye, I see what you are saying there in the comment section, but I think the variable in the middle is the one that is problematic. Okay, the variable in the middle is the one that is problematic. A converging series, guys, okay, what do we know about a converging series? If they are saying find the value of x for which the series will converge, then that means the condition for a converging series is that r must be greater than -1 but less than 1. Okay, yeah. This series is that type of series where r is greater than -1 but less than 1. So what do we need then to find if we know a series that converges has r that is greater than -1 but less than 1? Tina, we want the value of x for which this series will actually converge. So this is our starting point. Okay, we know that about converging series. Okay, we know that. Secondly, then, that means we need to find r in terms of x. We need to find what? R in terms of x. How do we calculate, guys, the value of r in a given series? To find r in a given geometric series, okay, how do we calculate the value of r? Because once we have r, we are going to take him, substitute him here, and then use our knowledge of solving a compound inequality from grade 10 and solve for x in that compound inequality. So that's why we need to find r in terms of x. Then we take that constant ratio, substitute it into this inequality, and solve for x the inequality using our knowledge from grade what? Grade 10. Okay, are you with me, guys? Can you follow my logical trail of thought with these types of questions? These are very common questions that get asked under the topic of converging series, a series that converges. After you guys do geometric series, okay, remember a geometric series is simply a geometric sequence in which you can actually find the summation of that geometric sequence. All right. So if you want the sum of a certain number of terms of a particular geometric sequence, then you start talking about a series. All right. Yeah. A sequence is simply a list of terms that have a constant ratio, but that's a geometric sequence. A geometric series is simply a sum of those terms in a sequence. Okay, that's just the difference. Are we together? A sequence is just a list of terms. A series, you are going to see plus in between the terms because we are adding. It's a summation of the terms that are listed. So when we talk about a geometric series that is converging, a geometric series that converges exhibits this particular quality. The value of R the value of R, which is the constant ratio of a geometric series, is greater if it's converging. It's greater than -1, but less than 1. That is what we know about a converging geometric series. So step 1, let us write that condition for geometric series that is converging, that R is greater than 1, greater than -1, but less than 1. 2, we need to find the value of R in terms of what? In terms of X. How do we find the value of R? We simply go there. This is term 1, 3 into X minus 1. This is term 2, X minus 1, the whole thing squared. This is term 3, 1 over 3 into X minus 1 to the power 3. So what do? I simply find R. How? I say R is equal to T2 divided by T1. Thank you, Cruz. Cruz, you are cruising, Wena. You are cruising with me. I need those who are lost to say to me, sir, we may not fully understand you, but we are hearing what you are saying. And if you are not hearing at all what I'm saying, then I need you guys to indicate in the comment section that, sir, we are not hearing you at all. The silence is killing me. Like people are quiet and I don't know if whether they are hearing me or maybe they are not hearing me at all, or like they are lost but they are not saying. And then like I finish the problem and then at the end someone comes up and is like, sir, can you please start at the beginning and explain everything? VKB boys, F boys, VKB F boys, you are lost, you are lost, you are lost. Okay, can I ask you, where are you lost? Did you hear me read the statement of the question? Consider the following geometric series. VKBF boys, do you know what a geometric series is? I heard about geometric series. I did not follow different from geometric sequence. Okay, right. Okay. Yeah, I explained it. You see, I did an entire lesson on geometric sequence and explained the difference between a sequence and a series. So guys, your geometric sequence, like the sequence itself, all right? Just give you an example here. Let's just say a sequence, right? A geometric sequence. All right. The sequence 2, 4, 8, all right, is what type of sequence? It is a geometric sequence. Why do we say it's a geometric sequence? It's because a geometric sequence, guys, has a constant ratio. In other words, if you check what is the division of term 2 by term 1, and you further confirm it with checking term 3 divided by term 2, you actually find that they have the same value when you divide consecutive terms. Term 2 divided by term 1 is actually going to be 4 divided by 2, which is 2. Term 3 divided by term 4 is going to be 8 divided by 4, which is also 2. So that's why we say the ratio, okay, because ratio speaks to fraction, is constant. The division is constant. Constant in the sense that this is the same answer. The word constant means the same, all right? So this is a geometric sequence. This is simply a list of terms. All right, but the minute you say 2 plus 4 plus 8, I am taking the very same sequence, which is geometric, and it's no longer a sequence, but now it is a what, guys? What is this now? Okay. This is still the geometric sequence, but it's no longer a sequence, but now it is a what? It is a series. Why is it a series? Because we are talking about the summation, the addition of those geometric sequence terms. All right, and therefore I can say that 2 plus 4 plus 8. The beautiful thing about a series is that we're talking about the summation of the terms. So for these 3 terms, if I'm talking about the sum of these terms, then I'm going to say the answer is 14, just for the first 3 terms, right? Because I'm adding them. So guys, a series is simply a sum of a particular sequence. So it's the same thing with an arithmetic. When we talk about 1, 3, 5, 7, all right, this here is not a series, but it is a sequence, because we are talking about a what? A list of terms, all right, that are consecutive. There is a constant difference here in this sequence, and because there is a first constant difference, in other words, if you take T2 and you subtract T1 and you confirm it by checking T3 and subtracting T2, you are going to find that the value is the same. There's a constant first difference, all right? And so we call this an arithmetic sequence. But the minute you introduce a summation for those terms that are listed there, then we are no longer saying that this is a sequence, but it is a what now, guys? It is a series, and from a series you can get the sum of those terms. Okay, so when I say sequence, I'm talking just about the list of terms, but when I say series, I'm talking about the summation of the number of terms that are given. All right, that is the difference, and I need you guys to be clear about the difference between the two. So Sim is saying, sir, am I correct if I say a sequence, you'll see it with commas? Yes, so you'll see it with those semicolons, right? Yes, you'll definitely see it. But then a series, you are going to see it with the plus, and sometimes there can also be a minus, you know, between the terms, but you won't see the commas separating the terms. You'll see a plus. So I think that's a beautiful way of just sort of like putting it to bed, that a series plus, or you can see minus between the terms, no commas, no semicolons. But a sequence, guys, will have those commas. All right, okay, simply put. I hope we are clear now. But now, guys, there is a specific type of geometric series that we talk about here that is a bit, you know, special, if you would call it that. We call that geometric series a converging geometric series. We call it a what? A converging geometric series. So a converging geometric series is a series whereby the constant difference, when you actually calculate the constant ratio, sorry, not the constant difference, the constant ratio. In other words, when you calculate R is equal to T2 divided by T1, we find that the value of R is always going to be between -1 and 1. It will never be a value that is equal to 1 or equal to -1, but it will always be a value in between -1 and 1. In other words, we say R is greater than -1, but it is less than 1. That is what a converging series shows us. Okay, so if we look at a question and it says consider the following geometric series, but you can see the series is in terms of another variable, and then they say to you find the value of x for which the series will converge. In your head you're like, okay, I know that a series only converges when R is greater than -1 but less than 1. All right, therefore let me then go to the given series. Let me find R. Let me find the value of R. How? By taking the terms, term 2. So in this case, term 2 we know will be this term here, x minus 1 the whole thing squared. We take that, and then what do? We divide that by what? By term 1. Where is term 1? Here is term 1. So x minus 1 the whole thing squared divided by 3 into x minus 1. You will confirm it, of course, by taking term 3, which is here, and dividing it by term 2, which is the previous term. Because at the end of the day, in terms of x, because we want R in terms of x, in terms of x, we should, in essence, get the same answer. All right. So we're going to check this, obviously, okay, and see if it really does, in actual fact, yield this same answer, right? So let's check this out now. Now here, it's always, to me, giving. It sends me right back to grade 10, because this is how, when you would simplify a algebraic fraction, right? Look at x minus 1 the whole thing squared. You have bracket there at the top, which makes this one term, and then in the denominator you have 3 and a bracket, which makes it another single term. The x minus 1, there's one x minus 1 at the bottom, and there's 2 x minus 1s at the top. So I can cancel here. Does that make sense? The x minus 1s, because they are in brackets. Then, because there's 2 x minus 1s, the one at the top, when I cancel with this one, there's only 1 x minus 1 left at the top. But what about at the bottom? At the bottom, there's only 3 that is left behind. Because 3 was in the denominator, it is alone left behind. So my R value in terms of x is going to be x minus 1 over 3. Okay, does that make sense? Then I said to you, we can confirm this looking at the T3 divided by term 2, because we should still get the same answer. Let's go and check this out. Okay, if we look there, we cancel again, right? There is 3 x minus 1s, but at the bottom there's 2. When I cancel, 2 disappear at the bottom, 2 disappear there, but I have 1 left. So here I have 1 over 3 x minus 1. Okay, 1 over 3 x minus 1. There's 1 left at the top with 1 over 3. Final answer, of course, because this is 1 over 3 x minus 1, this is the same thing as x minus 1 over 3. So all in all, guys, all in all, we have the same answer that actually comes about. R in terms of x is x minus 1 over 3, which is the same thing as 1 over 3 into x minus 1, because this can be written as x minus 1. Remember, this 1 and the x minus 1 are in the numerator together. You can multiply them, and then the 3 is in the denominator. Okay. Remember, if you decided to open two brackets, this will just further help you in your cancellation, because you will know exactly that, okay, I cancel the 2, this x minus 1 and this x minus 1. What gets left behind? 1x minus 1, that one, over what? Over 3. Okay? Remember here, if you opened 3 brackets, because you could, 3x minus, you're going to open x minus 1s, 3 of them, and then here you're going to open 2. The 2 are going to cancel out, and then you are going to be left with 1 at the top again, which basically leads you to the same answer. Okay, so at the end of the day, when we simplify, guys, all right, remember this is already at the factorized stage. Factored stage is where we can cancel out. All right, we don't expand further and FOIL. No, we cancel when there are factors that have the same bracket at the top and at the bottom. Yeah. Because remember, it is, yeah. In maths language, it's cancelled, but actually it's divided by. Yeah, that's true. Yes, Ngwatu. Yes. Okay. Remember, for division, the cancellation simply means that you are dividing. All right. Yeah. So, of course, there's 2 of these. There's 1 of these. So, these 2 divided by this 1 leaves only 1 x minus 1 at the top. Does that make sense? So that's pretty much how we do that. Okay, but remember, we were not wanting to just find r in terms of x. Once we have that, now we can go back to the condition of a converging series and substitute the r value in the place of r. And I'm going to show you how you do that. So now you have -1 less than, remember, r less than +1. -1 x minus 1 over 3. So now we are going to solve for x. And this is, again, back to what? Which grade? Guys, do you remember grade 10? Compound inequalities. When you first got introduced to inequalities in grade 10, all right, linear inequalities, you were also exposed to compound inequalities, where the whole objective is to actually make sure that in the middle we only have the x alone. Everything else needs to say goodbye. We need to say goodbye to everything else. So what we tend to then do something in the middle, and whatever we do in the middle, we do here on the left and we do there on the right. So the first thing we're going to do here is we can see that x minus 1 is divided by 3. So what we are going to do is we are going to multiply the middle by 3 over 1. Why are we multiplying by 3 over 1? It's because we want to get rid of the denominator. All right. But remember, if you multiply by 3 over 1 there, means you're going to multiply by 3 over 1 on the left. You are going to multiply by 3 over 1 on the right. You do the same thing you have done in the middle. Then what does that do in the middle? It leaves you with x minus 1. Okay. Remember, 3 divided by 3, you are left with 1 in the denominator, but that 1 in the denominator is not of significance. You can just simply write x minus 1. Okay, over 1 in the denominator does not really affect the fraction. But remember, if there was the 1 in the denominator, we'd have to write, if there was a 1 in the numerator, because of cancellation, and there not being anything in the numerator, we would write that 1 if there was a 1 in the numerator. But x minus 1, the cancellation there, it leaves us with 1 and 1. And then we know x minus 1 times 1 gives us x minus 1 in the numerator. 1 times 1 in the denominator simply leaves us with 1, and that 1 is not of significance. We can simply write x minus 1. What happens this side? What's 3 times negative 1? Negative 3. What is 1 times 3? It is 3. We're getting close to the answer. Now, what's the next thing we need to do? Get rid of negative 1. How? How do we get rid of negative 1? We use what we call the additive inverse. You add 1 to get rid of this negative 1. But remember, if you added 1 there in the middle, what do you do at the left? You add 1. What do you do on the right? You add 1. Then what do you get as your answer? What's negative 3 plus 1? Negative 2. What do you get in the middle? Okay, Classic Presh is saying you add 3 both sides. Be careful, Classic Presh. You said add 3 both sides. Okay? No. We were left with x minus 1. Remember, it's the middle that is our guide as to what we need to do. Initially, in the beginning, we had x minus 1 divided by 3. So we used the multiplicative inverse and we multiplied the entire fraction by 3. Why 3? Because in the denominator we can see there's a 3. So we multiplied by 3 over 1 to begin with. But what we do in the middle, we also do on the right. We multiply by 3 over 1. We do on the left. Okay, and right, multiply by 3 as well. Okay, then after that you proceed. 3 times negative 1 is negative 3. Then this 3 and this 3 leads you to 1. Okay, and you're left with x minus 1 times 1, which is x minus 1. 1 times 3 gives you 3. Now you have this negative 1 that you need to get rid of. You want x to be isolated at the end. So how do you get rid of negative 1? You use the additive inverse. In other words, the opposite of negative 1 is plus 1. That's how you get rid of the negative 1. But remember, if you're going to add 1 in the middle, you have to add 1 on the left, then you have to add 1 on the right. Then what does that leave you with in the middle? It leaves you with x. Negative 3 plus 1 leaves you with negative 2 on the left. Then 3 plus 1 leaves you with 4 on the right. What is your answer? When x is greater than negative 2 but less than 4, those values are the values of x, the values in between negative 2 and 4. Those are the values of x if you were to substitute into this equation. As long as x cannot be 1, those are the values that will ensure that your constant ratio is going to be between negative 1 and 1, therefore ensuring that your series is a converging series. Because take any of those values between negative 2 and 4, as long as x is not going to be 1, we exclude. In other words, we are going to say, yes, it can be any value between negative 2 and 4, but x cannot be 1. X cannot be what? It cannot be 1. We exclude 1 in that family because it is a restriction that was placed even in the question itself. But we accept any other value between negative 2 and 4, accepting that x cannot be 1. Are we together? So I repeat this again. What are you saying when you are reading this thing? Okay, you are saying x. Now, this inequality sign, it's like the mouth is opening towards x. I usually, like, I don't know if you guys know Pac-Man. Is it Pac-Man? I think it's Pac-Man. The game called Pac-Man. Yeah. But Pac-Man, I mean, if I was Pac-Man, I would never, I would be interested in partaking or eating something that is big, not something that is small. So what I'm saying is that when you read this, you say x is greater than -2. Please, guys, we read from x is greater than -2. Okay, any value after -2 that is on this side is a value that is greater than this value. So we say x is greater than -2, but less than 4. I repeat, x is greater than -2. So it has to be a value that is greater than -2. It has to be a value on this side. It can't be -3, -4, -5, No. It has to be the values that are this side. All right. All real numbers that are greater than -4. I mean -2, sorry. But they are less than. They need to be below this value of 4. All right. So that's how you read that. Someone else could actually write this answer in interval notation and say 2 to 4 with open brackets. Because remember, when there's no equal sign, we use open or round brackets. Okay, so that's saying x is between -2 and 4. Okay, I hope that makes sense. X is between -2 and 4. Okay, which is like the same thing as saying x is greater than -2 but less than 4. We do not include -2. We do not include 4. And the reason why we say x cannot be 1, guys, is because in the statement of the question, the x cannot be 1 was there. So that's why I am actually making sure that in my final answer, even though I wrote this, all right, I also include my restriction, because I don't want someone thinking that I'm saying all values of x are fine as long as they are between -2 and 4. There is one exception here, and x cannot be 1. Okay, I hope it makes sense, guys. So that's why I say x cannot be 1. It's because it was in the statement when I was reading through my question, and I saw, oh, okay, then it means since my answer here for x is between -2 and 4, let me make sure that that restriction is also stated so that it's not something that I take into consideration and include. Okay. All right. So these questions, guys, are not difficult. Let me just repeat again. Let's look at the question again. Consider the following geometric series. There it is. As you can see, the first term is in terms of x. The second term is in terms of x. The third term is in terms of x. Yes, Classic Fresh. That's why if there was an equal sign, then we would use your square brackets. But because there's no equal sign, we use open or round brackets. So as I was saying, the question here, first term is in terms of x, second term is in terms of x, third term is in terms of x. It is a geometric series indeed. It is a series because you can see in between the terms there's a plus, this term there's a plus, this term there's a plus. All right. Then they told me that x cannot be 1. There's a restriction that x cannot be 1, but I want the values of x for which the series will converge. And therefore, I explained to you that the word converge, what does the word converge mean for our geometric series? It means that your value of r, your constant ratio, common ratio, is greater than -1 but less than 1. That is what we mean by when we say a series is converging. They want the values of x for which the series will converge. So we know that this is the inequality that we are going to be working with as far as the constant ratio is concerned, because this is the condition that must be in place for a series to converge if it's geometric. So then our next step is to find R. What do we mean by R? The constant ratio. Why do we want to find the constant ratio? We want to find that constant ratio in terms of what? Of X. Yes. Okay. Then you find R how? You go and write down the formula for the constant ratio. R is equal to T2 divided by T1. This is your constant ratio formula when you want to find the constant ratio. You can further confirm that constant ratio by not only taking T2 and divided by term 1, by also taking T3 divided by term 2. You don't necessarily have to do this, because the minute they say to you, consider the following geometric series, that means that the constant ratio is going to be constant whether you like it or not. So you are doing enough when you just calculate the constant ratio in terms of X just by using T2 and T1 and not confirming it with T3 and T2. I am just doing that because I want to, really put it into your mind that when they say the series is geometric, the ratio is constant. It should be constant. It goes without saying. All right, it goes without saying, guys. In grade 12 CAPS, the converging series is our primary focus. We are explicitly asked questions on finding X, or finding the constant ratio, or proving that a series that is geometric is converging by finding the value of R and so forth. But diverging series is not explicitly examined in grade 12. It is a concept that you need to just understand as to what it means, because obviously diverging does not mean that the ratio is between -1 and 1. All right, it means something else. Okay, so it's a matter of understanding the concept itself, but not necessarily that you will have to understand it for examination. Okay, it's a matter of just understanding what the concept means. So you are not going to be explicitly examined on a diverging series in the grade 12 context. All right, so that's just something to note, because you must know what's examinable and what's not, and therefore it's sort of like where to play. So the person who was saying, let me check diverging, don't worry about being examined on diverging. What you need to worry about is understanding the concept of converging, understanding how it is examined, and then knowing how to actually answer questions around exam questions around converging series. Diverging, you just need to have a mental understanding of what a diverging series is, and that's it, just the concept. But you won't be examined explicitly about it in the way that you are with a converging series. So that's why I'm kind of like spending a bit of time and trying to really like drive this thing. So once you know that you are told that it's converging, this is what it means as far as your constant ratio is concerned. It's between -1 and 1. 2, find that constant ratio by using the formula. Then once you have your constant ratio in terms of that variable that you need to find, you take that expression, go and substitute it in the place of R, and then you go and solve that grade 10 compound inequality. So your grade 10 compound inequality skills need to come back, because you need them now in grade 12 as you are solving problems around your converging geometric series. Because if those skills don't come back, and if you don't ensure that you know exactly what ought to be done, then what's going to happen is that you are going to struggle with getting to the values of X, because you have basically not sharpened your skills around this idea of solving an inequality, a compound inequality, where They are, you have to apply your multiplicative inverse. There's division of 3, you multiply by 3 in the numerator. Then after that, there's subtraction of 1, you add 1. But what you do on the middle, you do on the left and right. What you do in the middle, you do on the left and right, and then you get to the answer. You see? And then that way, easy peasy. Okay? Thank you so much, Miss Zim. In the comment section, guys, just take note of what Miss Zim has said there. Valuable comment. The mark allocation, guys, don't stress yourself about it too much now. What you need to really stress yourself about is the question. Do you understand the concept that is behind the question? That's the first thing. And then do you have the appropriate and correct approach to being able to answer that particular question, the step-by-step approach? We need to iron out that. Once that is sorted, then the marks, they will just come to you because when you are doing what needs to be done and you know what ought to be done. So thank you so much. A valuable comment there from Ms. Sim in the comment section. Really appreciate that comment. So yeah, guys, that's basically what we mean by this thing, finding the value of x for which a series converges. Okay, yeah, there's nothing much to it. Right, guys, I want to close on this note. This is the last question I'm going to do for today. Yeah, and I know you guys are going to be like, yo, but say, come on. But guys, this is the last one. Let's do the last one. Yeah. Look at this question. The sum of the first n terms of an arithmetic sequence is Sn is equal to 4n squared minus 5n. Find the value of the 8th term. Find the value of the 8th term. I repeat, the sum of the first n terms of an arithmetic sequence. The what? The sum of the first n terms. Remember, guys, Sn means exactly that. The sum of the first n terms. That's what this means, Sn. Of an what? Arithmetic sequence is this. There it is. So we are given the general formula. The sum of n terms of an arithmetic sequence is 4n squared minus 5n. The question says find the value of the 8th term. Question is, how do we find the value of the 8th term from the sum formula or the sum? Okay, so guys, there is a concept here as well that we need to be aware of as grade 12 learners. In your formula sheet, the formula to actually getting the 8th term is not there, but I want you guys to know what it is that is to be done. Classic Presh, I see what you are writing there in the comment section, but let me say, unfortunately, that is not how we would get the 8th term. What you have just done, okay, is you have done a good job. Guys, look at Classic Presh's comment there. I'm gonna pin it. Oh, actually, it doesn't want to pin. Classic Presh did this. Took 8 and substituted in the place of n, and then substituted 8, right? But let's read what is it that my classic Presh has just done. All that she has done, guys, is she has found the sum of the first 8 terms. So that value that you got, classic Fresh, 216. This is the sum of the first 8 terms. The question is wanting the value of the 8th term. I want the 8th term. Okay. We want the 8th term. So take note of the question. But yes, Presh, if the question had said, find the sum of the first 8 terms, you see this approach would have been 100% correct. And we would have given you full marks, classic Presh. Okay. I want you to take note, Loandle there. Seems you can see the people that have been doing the things. Loandle, you can see Loandle has really Loandle, surely you should have finished the syllabus for sequence and series, because when you are writing stuff there. Okay. Yeah. So here's the deal. To get the 8th term, we take the sum of the first 8 terms and we subtract the sum of the first 7 terms. That's how we get the 8th term. The sum of the first 8 terms minus the sum of the first 7 terms. I want to sensitize you to something. Maybe some of you are looking at this and like, Aibo, what is that? Doesn't make sense. Let me just for a moment, please entertain me. All right. Do you see what we have here? Right? Yeah. So how many terms in the series do we have? 1, 2, 3, 4, 5, ne? Okay. Let's say I wanted term 4. Okay. If we look, actually let's extend this a little bit. 1, 3, 5, 7, 9, 11, 13, 1, 2, 3, 4, 5, 6, 7, 15, 17. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I think now it's a bit more nice, ne? I just want to I want to sort of like help us to I want to use an example to explain this, right? But before that, let's just take this idea that to get term number 8, 1, 2, 3, 4, 5, 6, 7, 8, in other words, to get 15, we take the sum of the first 8 terms, we subtract the sum of the first 7 terms. Sum of the first what? 8. So I'm going to just bring my calculator close here because I want us to practically look at this thing. All right, because look, this means that if I want term 8, I need the sum of the first 8. Term 8, I need the sum of the first 8 minus the sum of the first 7. So this is like I'm going down by 1 and checking the sum of the 1 less than this total number of terms, right? So let us just for a moment take the first 8 terms here and add them together, because I want to see, do we get 15 if we take the first 8 terms and take the sum and subtract the first 7 terms? So what's the sum of the first 8 terms? That's 1, 2, 3, 4, 5, 6, 7, 8. Let's add all of these numbers. 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15. And tell me what the sum is here. I want to write that down. The sum of the first 8. Someone else, tell me what the sum of the first 7 is. You add all of these numbers up until 13 and tell me what the sum of the first 7 is. I want to subtract those two numbers and see if we get term 8. Term 8 is supposed to be 15. if this formula is actually like true and it works. So I'm hoping someone in the comment section will, when they've found the sum of the first 8, will tell me in the comment section that the sum of the first 8 is this total. And then they'll say sum of first 7 is this total. And then I'm going to subtract those two and check if I get term 8, which should be 15. It should be, if this thing works, right? It should be like that, right? Okay, Ritabile is saying the sum of the first 7 is 49. Okay, so it's minus 49. Question is, what's the sum of the first 8? $64. Thank you, thank you, thank you. Right, guys, what's 64 minus 49? Do we get the 8th term indeed? Is 64 minus 49 equal to 15? Because if it is, then it means this formula works. Okay, Mzala, it is. Thank you. Thank you, thank you, thank you, thank you. So let us generalize. Tn is equal to Sn minus Sn minus 1. This here is the general formula for finding a specific term when we are given the sum formula of that particular series. Remember, if we substitute 8 here, then it means it's 8 that's there, but then 8 minus 1 will give me 7. If I want term 5, it means I substitute S5 here, but then it's going to be 5 minus 1, which is S4. If I substitute 12, because I want term 12 in this particular sum formula, then it means I'm going to substitute 12 here, and I'm going to say 12 minus 1, which is going to be S11. So S12 minus S11, because I want term 12. So in other words, I am saying to you, we can find any term in the series using this general formula. And this is something I want you guys now to actually make sure that you write down somewhere and you keep safe, because it is going to come very handy. This is a formula that is not in the formula sheet. In your formula sheet that you get for exams, this is not a formula that's in your formula sheet, but it's a formula you need to know, because there's oftentimes situations where you are given the sum of the first n terms, and then maybe they say in the question, give us the first 3 terms of the sequence. Imagine if you are required now to give the first 3 terms of the sequence. That means you are going to have to get term 1. You are going to have to get term 1 using this formula, get term 2 using this formula, get term 3 using this formula. And you know, if you want term 1, then it's going to be S1 minus S0. If you want term 2, you are going to substitute S2 minus S1. If you want term 3, it's going to be S3 minus S2. Okay, so all in all, what I'm saying is that this is a valuable formula to know, so that you can be able to find any term when you are given a specific sum of the first n terms. Okay, so I hope you have noted, guys, this very, very, very important, valuable formula. All right, are we together, guys? Are we together here? Like, okay, I see you guys found Eben. Oh no, don't tell me it's that 67 trend you guys are doing again. Okay, Eben Fermark seems to always come in here and do the same thing. Okay, I think I think we need to do this to Eben, because I don't want to see this guy again here. right? In the beginning it was cute, but it is not anymore. Okay, all right. Yeah, I know, I can see it's very possessed, but bye bye. Yeah, it's the link is in my bio, Emmanuel, if you want to the YouTube channel. All right, that's basically where I post these videos that I've done here on the live after I'm done, so that people can watch these at their own time, their own pace, you know, under the different conditions when there's not too many people and stuff. So guys, term 8, simple, you know. Now we know Tn is equal to Sn minus S to the subscript Sn minus 1. So there we go. Term 8 is equal to sum of the first 8 minus the sum of the first 7. So all we do then is we go there and we substitute 4 into 8 to the power 2 minus 5 into 8 minus, do the same thing, 4 into 7 minus 5 into 7. And then honestly, you just grab my calculator and all right, just put everything in there, you know. I have S8, which is like my first bracket, and then I have S7, which is my second bracket, and you just put everything in there and you just whoops, calculator, and it serves the purpose. I think sometimes some people like getting the actual sum value for this. They will write it out and then minus the other value, and then they'll write the final answer. So it really depends on what you want to do, but yeah, you see. So S8 is equal to 216. Are you sure, my good friend? 216? Oh yes, definitely 216, because someone had actually found S8. You are correct. Minus, then S7. You find the value of S7 as well. Ritabile, thank you so much for being quick there. Quick thinker there. Quick on your feet there. Ritabile, I see. Then you substitute there with the 7. You get S7, you subtract 216 minus the sum of the first 7 terms, and you get your answer. All right. Yeah, guys, man, it's nice. Just quick, straightforward, to the point. No problems. All right. Okay, is it 161, the other value, classic Presh, or do you mean the entire answer? Did you get one? Okay, let me just confirm. I think it's key that I confirm these things. Let me not take for granted. All right, yes, it's 161. Thank you, classic Presh. Then you say 216 minus 161, and then that gives you the voila answer, which is term 8 is actually equal to what? 255. Right? Sweet, sweet, sweet. Okay. Okay, guys, I think, yeah, let's hold it right there for this evening. Right, let's hold it right there this evening. Thank you so much for joining in. Really appreciate it. We continue on the battle, guys. Hi, man. When I Clive, you are a funny person. When you are a funny fan. So guys, I upload these live lessons after I'm done. You know, it takes a while though. I upload them. So the link to my YouTube channel is in the bio. And yes, the quality is not the best, especially with the live lessons when they are uploaded, because it is that TikTok quality, if you know what I mean. So I upload them raw as they are. There will come a time when I will become a bit more advanced and I will have resources that will allow me to, you know, sort of like have better quality stuff. But for now, it is what it is. So yeah, you can always check out that, you know, stuff in that YouTube channel at your own time. You can rewatch as much as you want and review what you need to review when you ought to review it, you know. So all of this is just to sort of like get us all familiar, guys, because I feel like the more, you see, the thing is, it's like a relationship. The more you spend time, you know, when someone wants to know God, like you must spend time in the Word. You spend time in the Word, and hopefully you get someone like I think it was, who was it? Philip, when he went to that Ethiopian eunuch that was reading the book of Isaiah, and he had no idea what he was reading, but he read some prophecy about the coming of a lamb that would be slaughtered, and he had no idea what it was speaking about. And this guy was riding in his chariot, and Philip comes along. It's one of the disciples of Christ, and he starts explaining and he starts revealing to this guy about the meaning behind what it is that he was reading. And the minute this guy had a sense of a revelation of what was actually happening, and had a realization that the lamb that was being spoken about in Isaiah 53 was actually like Jesus Christ, the Lamb of God that was slain and sacrificed, because this is all happening like in the book of Acts. This guy was like, I want to give my life, I want to be baptized. And so Philip went ahead and baptized this guy, and he came to really have a faith and a deeper relationship with God. And I'm sure this guy probably went back to his hometown and he began to preach the gospel, and he was able to be the means through which God was able to work. In essence, what am I saying? The more time you spend, you could say in a sense I'm kind of like playing a Philip role here, because what am I doing? I'm unraveling and revealing, and maybe like you guys are saying, Mzala is saying, you make maths look easy. I feel like I don't have that skill, but at the end of the day, whatever God is doing, he's doing it, and I'm glad he's doing it and is helping you. How ultimately you must take that and run away with it, so that it can benefit you, it can help you, and then ultimately, if you want to be better at it, go and explain it to someone else who doesn't know it, and see how much you will grow in your understanding. So what I'm saying in essence is that, guys, take good heart. Make sure you go and have the confidence to go and do more problems, practice more problems. Do not limit yourself to what I've done here and think that's it, so has covered everything. No, guys. Go and practice. Go and do more. And I'm happy to entertain your questions if you have any others. Okay. Saint Drizzle, what will be the 10th term? Well, there's the general formula. All right. There's the general formula. Okay. That means you are going to say T10 is equal to S10 minus. Then when it means 10 minus 1, that means S9. So S10 minus S9 will basically give you the 10th term. So you go and substitute here, you get the 10th term that way. Okay. So as long as you know this formula, there it is. What is term 10? T10 is equal to S10 minus S9. You substitute that into this formula, and then you solve. You get T10. Okay. So that is your general formula to help you with that. So all in all, guys, just practice and put this into practice more and more, and allow yourself to spend time. The more you spend time with something, the better you become. There's a guy called Herbert J. Grant. I love this quote because he says that which we persist in doing becomes easier. Not that the nature of the thing has changed, but your ability to do that thing has increased. So functions, for instance, Mzala is asking, when will you do functions? I'll do functions after I'm done with sequence and series, because functions is the next topic after sequence and series in grade 12. All right. And then after that, it's trig. Okay. And that's term 1, basically, of your maths for grade 12. Okay. So it's sequence and series, it's functions, inverse functions, more specifically for grade 12. All right. But you need to obviously review what you did in grade 11 and grade 10 with functions, so that when you get into grade 12, you are getting into grade 12 with that knowledge intact, lest you've forgotten the things that you did in grade 11 and 10. Then after that, it's trig, you see. So let me have one more session with you guys with sequence and series tomorrow, all right, where I do sort of like a finish up of the exam type questions. Obviously, that will not mean that I will have done every exam type question. It just means I will have gotten to a place where I'm like, okay, that's kind of about as much as I will do, and you guys need to obviously continue to do more. And then after that, I will go ahead after tomorrow. Then I'll start with functions, and we can check that out. Okay. But yeah, guys, I think let me love and leave you. Thank you so much again, and thank you to everyone that joined. As usual, I love going through the list. Mzala Knowledge, thank you so much. Spuso Blessing, my man, thank you so much, man. I really appreciate the gifts. Like the 22 you awesomes that you sent. I think those were unexpected, but I appreciate them a buckload. Thank you so much. Miss Sim, always a pleasure. Always a pleasure. Thank you so much, especially also for your valuable contribution in the comment section. It goes a long way. I saw at some point, I think it was Boiti or Dumi was actually really appreciative of one of the comments that you actually said there, speaking about a particular thing that, I think you clarified very well. I think that was like putting the pluses in between, that the difference between it being a series when you have the pluses and then when it's a sequence when you have just the commas and the semicolons in between. So Opulence, thank you, brother. Thank you so much. Really a pleasure to have you. Born Claire 4180, thank you so much, dear. Future pilot Alt Simon. Okay, guys that are participative and comment and double tap and do all sorts. D, thank you so much. Mfunzo, Adrian, Ecstatic, Bondle, Kalipo, Piggy, Khetwa, Mbukhalo, Kolani, Njangase, Bandile, Star Girl. Okay, not the Star Girl, but I guess some Star Girl. I see the Star Girl that is quite star-ish. BK, SK Kumalo, Kungawo, Mabikwe, Bretana, Mahladze, Cats Rule, Tia Imfupi Kamo Kitsipi, Terry Pops Zulu 22 Oratilwe, Mr. K Male for Backroom Entertainment Hub. I am CJ Spusto Victoria Pamela Bonu, Moloko user Ndando Tenju Hayo Lindo the Boy, Mialisa Olu Kira Brainwiz IQ Bravo, Mapalela. Is it Mapalela? Yeah. Mr. Shark, because I see a shark icon there. TJ Gaming, Fig 777, Sambo Joy, and Noz with the umbrella. Thank you so much, guys. Thanks a ton. Have a great one, and thank you again. Till we meet again, which will be tomorrow. Simply with the soil man with the glasses, Percy and Oba gang. Cheers, guys. Cheers, and cheers again. What time, guys? Like I said, it tends to be not as stable, but 9 p.m. Let's just say 9 p.m. Because it will be tentatively any time after 9. All right? Yeah. But try 9. But it's just that, like I said, it tends to be other things that tend to also cry for attention. And if I do go live, then I go live. I don't. But guys, please make it a point that you're practicing, and you are pushing as well on your side. Thank you. Peace. Like peace from the Middle East.